Physics students, good afternoon, Mr. Fugit here. Today in this video we're going to be looking at some problems involving electrostatics, which deals with charges and how charges interact with one another. And specifically in this video we'll be looking at what we've called an electrostatic force or a Coulomb force that one charge experiences based on its close proximity to two other charges. And this video is geared towards problem number, I believe it's 2, on homework 13 over electrostatics. So I'm going to read our problem statement and also draw a representation of the picture that you're given in your homework. It says this: a particle with charge 2 microcoulomb is located on the x-axis at a certain point, and a second particle with a charge 6 microcoulombs is placed on the x-axis at another point. What is the magnitude of the total electrostatic force on a third particle with a charge of negative 8 microcoulomb placed on the x-axis at another point? The Coulomb constant is 8.9875 times 10 to the negative fifth. So to kind of get a better idea of what's going on, I'm going to draw a picture of what you were given in your homework. You're given something that looks like an x-axis and an origin point, say right here. Now again, as we go through this, remember that my numbers and values are a little bit different than yours, but the process of this problem is going to remain the same. So the first piece of information I'm given is a particle with a charge of 2 microcoulomb that is located on the x-axis at negative 6 centimeters. So we'll say over here, this is negative 6 centimeters, and our charge is 2 microcoulombs. And we are told it is a positive charge. And we're told another charge is located on our x-axis, this one at a distance of 6 centimeters, positive 6, so we'll say over here to the right of our origin, and this is 6 microcoulombs. And we're asked to examine the electrostatic force on a third particle with a charge of negative 8 microcoulombs, we'll do this one in blue, at a distance or location of 2 centimeters. So we have a third charge, negative 8 microcoulomb. Okay. Oh. I should draw the charges in there, that would be helpful for us. Okay. So I'm going to be referring to these charges as 1 in red, 2 in green, and 3 in blue. Okay. And I'm told here that my focal point is a charge 3. We want to figure out what's the total force going on charge 3. Now, as you can probably recognize, our main kind of focal point charge is charge 3, and it's a negative charge. So we should be able to determine before we do any mathematical solving that charge 1 is going to want to attract charge 3 because they are oppositely charged particles. So there's probably going to be some force to the left from charge 1. Now charge 2 is also positively charged, which means it's going to want to pull charge 3 the other direction. Okay? So we have a bit of a tug of war going on here. Okay? Charge 2 and charge 1 are both pulling on charge 3. So before we do any solving, it's important that we conceptually understand what's happening here. Okay? So now, once we know that, it's going to be our job to figure out, well, what's the amount of force pulling to the left? What's the amount of force pulling to the right? And when both of those are pulling on charge 3, what's going to happen? Who's going to win? What's going to be our overall net force? So the first thing I'm going to do is I'm going to find the force. I'm going to call this from charge 1 on charge 3. Now we know that we can find this electrostatic force using our equation. K times Q1 times Q, well Q3 is our other focused charge here, what we're looking at, divided by d squared, the distance between charges. So I'm going to plug in what we know, K. I'm going to use 9e to the 9th. I know your homework system does say to use the actual decimal value, but I'm going to go ahead and use this, keep things simple. Q1, our first charge, 2 microcoulombs, so don't forget to convert, 2e to the negative 6. Q2 is negative 8 e to the negative 6 coulombs, and we divide by the distance between particles squared. So 6 centimeters back to the origin, plus 2 is 8 centimeters, or 0.08 meters. That is d squared. So all we're doing is plugging in the variables that we know related to solving for our electrostatic or Coulomb force. So force from 1 on 3, we plug in and do a little bit of solving mathematically here. 9e to the 9th, 2e to the negative 6th, negative 8e to the negative 6th. Then we divide all of that by 0.08 squared. I'm going to get something that looks like negative 22.5. Now remember, when dealing with this electrostatic force, the negative doesn't necessarily tell us left or right. The negative tells us attraction or repulsion. So this negative, really all it means, as I mess it up, The negative just means it's a force of attraction. And that will be important when we come back to solving for the overall net force. And what we're going to do next is really just the same thing, except we're going to figure out, well, what amount of force does charge 2 pull on charge 3 with? And we know what charge 1 is doing. Now we want to look at what charge 2 is doing as well. So I'm going to say that this is the force from 2 on 3. And it's the same equation, okay, K, but now rather than Q1 and Q2, excuse me, Q1 and Q3, we're looking at Q2 and Q3. So it's still K, now Q2 and Q3 divided by D squared. So here we go. K, again, 9e to the 9th. Q2, we come back up to our picture, is 6 microcoulombs. So 6e negative 6. And then Q3 is negative, let's say 8. Make sure I'm not forgetting, there we go. Negative 8, e negative 6 coulombs. And we divide by the distance between those particles squared. So we come back up, distance from 2 to 6 centimeters is 4 centimeters. We convert to meters. That is 0.04 meters, and then squared. So now that we've set up our equation for electrostatic force from 2 on to 3, we'll do a little bit of solving. So K is 9e to the 9th times Q2, 6e to the negative 6th, times Q3, negative 8e to the negative 6th. And then we divide by our distance squared, 0.04 meters. And we get something that looks like about negative 270. So F from 2 on 3 equals negative 270 newtons. Now again, remember, the negative just means it's a force of attraction. It doesn't mean left or right. Okay, so now we've solved for both forces, but the question's asking us, what's the magnitude of the overall, the net force, if you will? So to put all these pieces together, let's think lastly about Q3. We solved for the force from Q1 onto Q3, and it was the force of attraction. So that force is going to want to point towards Q1. And this was 22.5 newtons. And we just solved for the force from Q2 on Q3. Also a force of attraction, so it's going to point towards Q2. And this was 270 newtons. Now, I really like to draw these pictures because it gives me a better visual of what's going on in the scenario. Okay? Now, as you can see, because these are forces of attraction pulling in opposite directions, to find the overall, if we want to sum our forces up, well, we would take 270, and I would subtract 22.5 newtons, right? They're in opposite directions, so when we sum them up, we'll treat the 22.5 as if it's in the negative direction. So 270 minus 22.5 gives us an overall force, we'll call this a net force, of about 247.5 newtons. Now when I check my key, see what we get. 247.5, there we go, 247.5. So we know we found the correct answer. I will tell you all one thing that you do need to pay attention to in this problem is that it does ask for the magnitude of the overall force. You all might get something that looks like this. Say your force to the left is 270 and your force to the right is 22.5. Okay? Let's say that the direction of those forces was reversed, right? If you sum them up, well, you would get what we would call a negative value because there's a greater force in what we typically define as the negative direction. But in this problem scenario, it's asking us for the magnitude of the overall force, meaning just the value. It doesn't really care too much about the direction, it's just looking for the magnitude. That way, no matter how you define positive and negative, it's just looking for the value itself. So, hopefully this will get you started going in the right direction on problem 2. Best of luck.